Okay, so welcome to, I'm going to be using C. I've set up a new console application. So I'm going to add a new item and we're going to call it main.c. So this is a way to create the just to create normal C programs because I don't want to do C++. So we do main.c and then we add it. We should be able to, should be able to just write in it. So let's just see if we can get it to actually work to start with, and then of course I'll move on to try and do it. Like I say, this is going to be very, very slow. I'm just going to see if it works first of all. Alright, so okay. So we use Printf, so that comes from the standard IO library. So it's just like stuff like comes from the library, like in Java it comes from packages and stuff like that. But like I say, I'm rubbish at this. And this is really going to be just to see if I can actually get anything to work. Let's say, then we'll do a new line there, and then we'll close it off. And then we have to return, and I'm not quite sure about this return thing yet. You can return different things, but for now that's all I'm going to return. So then we're going to try to execute it. We'll build it, of course, first. Alright, so it went to the new line. That seems to be okay. So I think everything's okay. Like I say, I still don't really understand this the whole compiling and linking, and these and the preprocessor gets these things, gets the include statements which direct to the only things which need to be on one line. I wonder if I did something like this, for instance, it doesn't actually change the output. There's nothing you can see. I guess it wouldn't really change anything, would it? What about if I do this? See if we get any errors now. No, you see, because you see, with the way it passes it, as long as you've got the include statement on a separate line, and as long as, like, obviously, if you have something like that, it's not a fucking real thing. But beyond that, I bet this one doesn't work. No, it still did. So you see, there's a lot of flexibility in terms of how much fucking space you can leave, which is cool. But normally you don't really leave any space because you want to just jump straight into the brackets, and you get these little yellow marks in Visual Studio. Well, the version I've got anyway, maybe it's the old version or something. But yeah. So what I want to do now then is I could probably do something more complicated than that. Let's go on to this. So the first thing I want to do is what I'm going to do is I'm going to set up a few lines at the top. This is going to be like, I'm not going to save any of this stuff I'm doing, because often I end up saving a load of stuff, and to be honest, it's so basic, this stuff, there's no point even saving it. I mean, I've got millions of files like this. Do you know what I mean? So it's almost like I'm just thinking, yeah, I'm just thinking, like, may as well just do things in a, just do as much as I can. Who cares about saving it? That's the idea. So this program is going to be. So we just call it what it might be called, right? It's just this is just for the comment section, and I'm going to be using these kind of comments. I kind of realised that I kind of like the comments like that. I think it looks quite cool, and then. So because the purpose, they say it's like print a line, and I'm just going to delete this over and over again from the standard IO library. That's where it comes from. .h, there's the C file extension. Print a test message using the, so this is how we could write it, printf function from the standard IO library. There we go. Okay, so put that in there like that, and then we could put any author, we'll just put wide, whatever. There we go. And because it's just going to ignore all that stuff, I can build it again, and it still works fine. Okay, so there's a very, very basic sort of hello world thing, and what I'll do is I'll change the name and the purpose as we move along, and do some more stuff. Yeah, so I could talk about yeah, now declarations and statements. Here's an interesting thing. So obviously variables have got to have a type. And what you can do in Java is you can either declare them and then instantiate them, or you can declare and instantiate at the same time. One of the things I've found is that the point to get to declare and then instantiate is so early on that it's almost not even worth bothering with the declare then instantiating. You may as well just go straight for both. But then again, I suppose if you've got a lot of different variables, it might be a bit of a problem. So we could, so what I might do, what I'm thinking of doing is, yeah, and I wonder if I could just, yeah, I mean, in theory I could just put anything in here, because that test message is not going to do anything. So I wonder if I could just extend the main function. I didn't really mean to do this, but I might just write a whole new one in a minute. So yeah, what's the best way to do this? So we could like say could we what if we instantiate a load of things? Let's try this. Let's just try this here. Okay, so instantiate those. Alright. No, so this is, sorry, we declare them, but we can instantiate them first, but we can't do it both at the same time. Alright, let's actually build it, because I'm looking at a program at the moment. So obviously, what I'd like to do, so we're gonna instantiate them all, and what we can do is we want to instantiate different types of variables. So we can already see what these we can instantiate all three of them like this. So we've actually got height, length, width, but we're going to need some volume as well, because that's going to be another variable. So we're going to instantiate that, and then what this this program is all about is about you know, for instance, if you get packages from abroad, what you can do is you can calculate how much it would actually cost to process them. And obviously, I'm sure this is something which is you know, fairly sort of yeah, it's an interesting problem though, isn't it? Like if something weighs a certain amount, and the real thing about this, before I even do it, the real thing about this is like it's all about. With programming, it's unlike me. I prefer maths really to programming, if I'm being honest. But they are kind of the same. But at the same time, what you've got to realise is that programming is more about truncation of values, so just lopping off the end, regardless. And maths, of course, is you would round it up. You wouldn't, you know, if you truncate 23.6, you're going to get 23, and if you round it, it's 24. But with when you're sending packages, obviously it makes more sense as the service provider to charge as much as you can, basically. But of course, to follow the rules in the correct manner. All right, so we've still got a float here. Now, a float is a more complicated. A float can deal with more than integers. It's like well, I wouldn't say it's real numbers. It's more rational numbers than real numbers. Yeah, I mean that's probably quite a complex point, and probably this, you know, if you're very good at say graphics programming, it's probably a more complicated answer to that. Okay, so yeah, these numbers 8, 12, and 10, these are constants. So they're constants here, basically. Yeah, I'm not going to use, like I say, one other thing that's important for me is that to keep things kind of messy at first, because if it's not messy, then it's not really working how you want. Now, yeah, okay, so you can see there's no declarations in the int main, and the main is very important term. Okay, we could actually put while I'm here actually, so ints can store so obviously ints can store positive and negative numbers, and i.e. You know, 2's complement. Well, I'm not going to go into that here. I'll do that when I do more assembly programming. But this is what it's talking about, really. Okay. Floats are slower than ints, just because there's more decimal points, and they're obviously it's an approximation of the number. All right. So they're less precise, maybe. Maybe. I have a feeling they're probably more precise, actually. In fact, what's the point of even putting that? They do work slower, though, because there's more digits. We can say that for sure, at least. Okay, so the next thing to talk about then, okay, so what we've got here, we want to say okay, so we've initialized the height over here, yeah. Then no, sorry, let me get this fucking right order for once. That's the thing. The problem is I want to keep things messy, and I don't want to get too pissed off at it, because I've done this many times before, to be honest, and I do sometimes get pissed off with programming because I struggle with it, and it's annoying for me because I've learned it so many different times that I probably should know it by now. But of course, declaration comes first. You can't initialize something you haven't declared. Interestingly, I believe as well that these floats, even by initializing it, it's actually already got a value. Oh, we get a little tooltip. I do like Visual Studio, I've got to say. It was a bit of a bastard for me to find out how fucking it even worked, but now I've done it, it feels like what I want it to feel like. I'm wondering why this. Oh yeah. Weird. I wonder if I'm going to a different place when I click those buttons. But anyway. So let's see what comes up now. Let's have a look. Nothing. And it's all worked out properly. That's because, that's good. It means that I've declared everything and I've initialized them. But I haven't produced any I/O effects for it to actually come on the screen. So I might want to do that. Okay, so the way this is going to work in C is what we do is we got the printf. We saw that right at the beginning, right? So what we need to do then is we need to establish, we need to have a placeholder. So we need somewhere to put the information in, because what we want to do is we want to say, well, the height is 8. We just want a line saying height : 8. Yeah. So what we need to do is, okay, so we've got a normal sort of like a string height. Okay, what happens now then? Well, we need to have a placeholder, and depending on the type of the variable that we're dealing with, if we're dealing with an int or we're dealing with a float. So for instance, if we're dealing with an int, what we need to do is we need to put %d, and then we can go to the new line again. And keep in mind this is all enclosed inside of a string, which is kind of interesting looking. But what it means, of course, is that this is more complicated. This is not quite working like I would imagine I've seen in Java. To actually, well, maybe it does work in Java. Maybe, I think C is just an easier language to understand than Java. Java is an interesting one. But anyway, the point is, right, if we simply do that, right, what we can do is we've actually managed, right, to print out this line. So we're going to print out the line height, colon, and then it's going to have one. There's going to be one gap. Let's just, I think, yeah, because the gap within the. Let's have a look. Let's have a look. Height 8. Yeah, that's good, doesn't it? But you see, I think this gap might make a difference. And now you may be wondering why I'm talking about gaps, but you know, honestly, the gaps. I've always found gaps to be the most annoying thing. I found all the programming as often. Whenever I've been thinking about programming, I thought about it. And eventually I just end up getting very stressed and thinking about the gaps all the time and the spaces and the little... I don't know why, but this is what I tend to do. So I'm not going to focus... well, I kind of am already focusing on it, but I guess I can't help it. But you can see, yeah, I mean, it's not a surprise it acted like that, to be honest. So yeah, if it doesn't act... The thing is, if something starts acting like in a funky way, then I might do something about it. But that is not really a surprise that I acted like that. All right. So yeah. So the key thing is we declare, then we initialize. One of these days I'll say it right. Di. That's it. Declare, then initialize. Yeah. We'll have to. Yeah. Well. Okay. So there are differences appears between an old version of C89 and C99, but I'm not going to go into that yet. I'm sure. Yeah, and I'm not going to go into. I mean, sometimes I see things about modern practice. The comment thing with modern practice is, you know, that's one thing. It'll be a bit awkward to have to put what are the comments things that I put at the top there. Anyway, so the next thing to talk about. Okay, so we've initialized profit. Now I wonder what happens if we I wonder if we can I'm not going to concatenate it first. Let's not concatenate it first. And what I want to do is I want to have so we'll say the profit is 2000.65. Should we make that the profit? Yeah, let's make that the profit then. Okay. So we're going to do the profit. Now I wonder if I need to, I think now, so we've initialized it as that. So let me just try changing this line and let's see if we can put the profit in there. Now the profit I believe should be like that. Now this may be where we get our first warning. Let's have a look. So it says it's 2000.65, so that is certainly, that should be okay. Let's have a look. Alright, let's have a look. I'll stop doing stupid things. Really? Oh my word. Alright, you should hopefully know about assignment by now. One of these days I'll fucking get it. Interesting. So Bill succeeded without any errors? No errors. So you can see that it's actually appended another 4 digits onto it. Now, where it gets these 4 digits from, I don't know. That is a very interesting question. But again, that's going to be something which assembly language will have to tell me. It's why assembly languages is in a sense more powerful. And it's why with Java you couldn't fucking get anywhere, because I didn't have a clue what Java Virtual Machine was doing. So there's no point really learning Java. This is one of the annoying things. The computer science, they tell you Java's crap, C is the best. Now learn Java. It's like... now, there is actually a way to do something even more complicated here. Yeah, so by default, %f displays a number with 6 digits after the... Okay, so what we could do here is if we do it like this, we have 2f here, we should get our number back properly. Let's try again. So there we go. That's how we can actually get a proper symbol. So with the float, it's %f, but if we want to have a certain number of decimal points after the decimal point, decimal places after the decimal point, then we put dot and then you know, as so. Okay. All right. We'll leave it at 2 there. Yeah. Okay, so that's looking good for now. So the next thing to focus on is that we need to start thinking about what this program is actually going to do. So we're going to go back to the start and we're going to start making some adjustments to this program. So the first thing we're going to do is now we're going to be having a program. This is a program about dimensional weight. So okay. And you know what? I'm just going to go. The thing is with me, you can't just, you know, like I say, I'm obviously following instructions, but at the same time, I've very much got my own way of doing things. And if I could in any way factor in, do you know what I mean? I'd almost prefer to have it like this, really. You know, I always like that in chemistry and stuff like that. Okay, so the method. Okay, so to find a dimensional weight, of a box, to find out the dimension of a box, what we have to do is we have to divide the number by 166. Okay, so the reason for that is yeah. We have to divide numbers. We also have to round up. We also have to round up. So this is a very, very important point that I was mentioning at the beginning. We also have to round up the number so the way you do this, right, is and I'm going to talk with some smaller numbers first. I'm just going to illustrate what's actually going on here. Okay, so say we had to divide the number by 5, right? Now, what we'd want to do is say our box, the volume was 20. If we divide by 5, the dimensional weight will be 4. If we have so if we have 23, say we add 3 to it, we do 23 divide by 5, our dimensional weight would be 4.6. Yeah, so just imagine this. So what we'd have to do is say we add 5 to it every time. Yeah, let me try and work this out, see if I can actually get it in my head. Yeah, so 20 divided by 5 will be 4. That'll be fine. But what we had to do is we had to add a certain amount to it each time. 20 divided by 5. So if we add 6 to it each time, yeah, we need to find a way that we don't have to round down. I might just actually use the actual numbers. Yeah, you know what? Let's actually just do it, because it's basically you have to do it so that whatever the truncation, it will always round up, so that 5.0001 is 6. And I'm trying to explain that, and it's difficult to explain because, like I say, it is an interesting problem. Okay, so if we had this, right, what variables are we going to need here? All right, so we're gonna mess around with the variables now. Let's just change this, and we're going to want height, length, width, yeah, volume, and we're going to need weight as well. Okay, and they're all integers. All right, so this is an important thing about converting from. Well, actually, we're not going to even use the floats here. Alright, let's forget about the floats for a minute then. Alright, so we've got our... Alright, so now we're going to do a volume, and we're going to make this, as you might imagine, okay, so height times length times width. And then we're going to do the weight, and then I'll try and get some good numbers in here, and hopefully we'll be able to do something interesting. Yeah, so this is the thing. And then we divide by 166. So let me just write down some of the times tables here. So the 165 times table is 330, 495. The 166 times table, 332, 498, right? Alright, so we have to up by 165 and divide by 160. So we got 1 here. If the volume is 1, then it will be 1. If it's 2, it will be 1. Okay, so we could say basically, let me just say that, yeah. So from this, so if, and this is almost it actually. In fact, this is the main line. So if we say the volume is 1, then the volume is 1, the weight is 1. If the volume is volume is 164, So we'll do 164, 165. It's going to be 329. And 329 divided by 166 is going to be 1. Now the volume is 165. Then it would be volume 165 would be 330 divided by 166. The volume is 1. The volume is 166. It's going to go to 332. 332 divided by 166. So this is basically what I was trying to say before. The volume is 1. The weight is 1. So basically any package that exists, it can't be less than 1. Yeah, I mean, and I assume that even the cardboard probably weighs that. So yeah, this is obviously. So you see, the volume only goes to 2 once it reaches 166. Actually, sorry, no, it doesn't, does it? No, that's wrong. Yeah, so if volume is 166, the weight is still 1. No, wait. If volume is 165, it's 1. 330 is 1, yeah. If the volume is 166, the volume is 166, it's going to go to 331. 331 divided by 166 is going to be, it's going to, weight is 1. So basically it has to be 16, yeah. So these are all these sort of yeah, so basically this section here, so volume is 1, the weight is 1, volume is 165, the weight is 1. If it's 166, it's still going to be 1 because the 2 digits here are not going to be add up enough. So if the volume is 167, the weight is 2. Okay. So that was just a little aside I wanted to mention there. Because yeah, we'll get 333 then, and that would not be enough. And that would not be enough to give a multiple less than 2. So yeah, it has to be basically greater than this number here. Alright, but maybe, yeah. So yeah. Yeah, so you can see what happens. 167 plus 165 is 332 over 166 is 2. So anyway, yeah, I spent a little bit too long on that. Now, yeah, I think I'm just going to leave it there actually. I'll probably do something differently I'll do a bit more in the next episode. So until then, thanks for watching.